Recording in progress. So welcome to lecture 8. So today we start project 7. All right, so one of your project 6 environments becomes project 7. Your choice. You pick one though, stick to it, because you don't want to start off going down one direction and then realize, oh, that's too hard, or I don't like it, and start off on another. You're basically going to have to start over. Now, part of the beauty of project 7 is that in theory, you've already got your lighting done and you've got some materials in your scene. Now, if you are not totally happy with your reference, this is a good time to change it out. If you realize after doing project 6, I wish I had done this, that is a good time to change reference. However, be very careful if you decide to scrap all your reference and start over, because then you're going to have to go find new reference, put materials on them, and then decide based on your reference, do I need a texture here to describe this material? So for example, in my render up here for textures part 1, you can see I've got some textures. All right, so I've got one here on the bread. I need a texture for that to describe it. I can't do that with a solid color. The cheese, there's a texture there. There's a texture on the cutting board. There's one on the table. There's one on the handle. There's one here in the label. There's one on the sofa here, on the cushions, my artificial grass. There's actually one on the asphalt back here. But the metal up here, I didn't need a texture to describe that. It is a solid piece of metal that's painted fairly uniformly. If you take a look at the reference from project 5, the photo reference, you'll see the Zen garden is mostly metal on those steel beams. However, the inset here, this part right here in the middle of the front, that is a wood grained inset. So you will need a texture to describe that. So I got wooden slats back here. These horizontal slats, you need a texture. For these vertical slats, just going to put HOR here. Okay, and for these vertical slats, they are mostly part of the steel frame. So I didn't need them. Needed a texture to describe that sign. But I don't need a texture to describe my wine bottle, right? It is a solid piece of glass. We've made it already. My wine glass, no texture. My wine, no texture. So not every object will need a texture or a map to describe it. Does that make sense? Now, if you're doing the interior, same thing will apply. Now, with the interior, though, some people will look at the wall, and for a real good example are the walls here at Full Sail. They are kind of average interior Florida walls, where they have this orange green kind of texture on it, where if you rub your hand on it, it feels kind of a little bumpy like orange peel. That is not as noticeable far away as it is close up. If you start to go back about 5 feet, 8 feet, 10 feet, that little bit of grainy bumpiness sort of disappears from the camera. You really can't tell it's there. So it depends on how close your camera is to certain objects, whether you need to have some kind of visible, what we call surface relief. Does it look like it's got little cracks in it? Does it look like it's got a bumpy surface or little indentations? Things that we would normally associate with touch. But we can see them, so our eyes kind of translate that into, oh, I know what that would feel like. Does that make sense? Questions? Anybody in Zoom? Does that make sense?
I'm all good.
Okay, Nelson's good. Thank you.
Makes sense.
Gaetano, makes sense. Julio, good, thank you. All right, so what you can do is just start looking at your reference and figure out, do I need a texture to describe that? Okay, my reference for the interior, I've got a really nice solid wall color. Well, you have to decide how far away is the camera in your reference. You want your camera to be more or less the same distance as your render cam. Figure out whether you need to put that orange peel texture on there or not. Chances are you really don't. Unless maybe at the close-up you might see it. But again, it all depends. All right, so today we're going to be doing some basic maps. File mapping methods. There are 2 main methods. One is the average texture mapping, which uses UVs. The other is something called projection, which is very similar to what Unreal and Substance has it. Unreal, Substance, and Unity, kind of mapping in a decal, where we put it in 3D space. We're not tied to just UVs. After break, we're going to be working in Photoshop, taking a brick texture and making it seamless or repeatable. This is a skill that you definitely want to have some experience in, because not every texture you get will be repeatable, meaning you repeat it over and over and over across the surface. And the more you repeat it, the more it scales itself. It scales itself smaller to repeat on the surface. It's really valuable to save texture space. But that kind of file needs to be done before you take it into Substance and before you take it into Unity or Unreal or even Maya, if you need it to repeat. If you don't need it to repeat, okay, you can use it just as is. All right, so got a couple downloads for you. We've got the Lecture8 new PowerPoint file that contains the seamless texture workflow for 3 different types of surfaces. We're only going to do one today, the brick wall, but there's also, I've got a wood floor and also kind of an alligator skin reptile hide that you can make repeatable. They each get a little more difficult in the process. We've also got an SAL logo that needs to be projected, and or the Thermos logo, which we provide for you for the interior kind of thermal bottle that's sitting on the desk. It's got a little logo right in the middle of it. And we've got a new set of templates for you. A little bit different than Project 6 templates. All right, so office hours next week, Tuesdays, Thursdays, from 10 to 4 p.m. Eastern Standard Time. Frank or Ari will be doing the Zoom Open Labs. Campus and online students, welcome. It's optional. Good time, good chance to get help in a group setting. Don't forget, we still have Discord that we run. And we've got, most of during the week, during normal business hours, we have somebody in staff there usually. On the weekends, you can post stuff. We'll get to it when we can. Sometimes students will help each other out if they know the answer. And that's really what we use Discord for, is to encourage you guys to help each other. Because that's kind of how you're going to build your troubleshooting skills and also how you're going to work in the future. You don't have to do something, throw it out there to the group. Hey, anybody remember how to do this? Oh yeah, here, you do this. That will help you in a work environment later on when you guys are working for somebody or working in a group. All right, so today, basic maps. Our basic maps for our class will be the diffuse or the base color, depending on what program you're using, specular, roughness, and a bump map for height. Now, I know in some classes you use normal maps. We prefer to use bump maps so you guys can understand what you can do with a very simple height map. Bump maps are much simpler than normal maps. Bump maps deal with the visual illusion of height or depth on a surface. Cracks, bumps, little indentations, little imperfections on the surface that we can see. But again, it's all illusion based on the angle of the normal on the surface to the angle of the camera. When the camera faces directly at the object, we see more bump than when it's at an angle. So file mapping methods, we got UVs, we have projection, which is X, Y, and Z. We're not just limited to 2 dimensions. Seamless brick texture after Photoshop on Monday. Kind of our resident substance guru, Anthony Bagsby. He's our associate course director. He's going to go and give you a little substance. Well, you're going to be working in substance that day. And he's going to kind of show you how you take stuff out of substance and bring it back into Maya. Now, you may or may not have had experience with it, but it's kind of important to know which maps you need and which ones are going to come out and how to use them, where to put them. Any questions so far? Everybody good? Questions, Zoom?
I'm good.
Good. Thank you, Nelson.
No questions.
Okay. Let's go take a quick look at project 7. So we're going to be exploring different texturing methods. Kind of the stuff I went over up here. So you're going to choose one of your environments. What you want to do is make a copy of that project 6 Maya project folder, duplicate it, label it project 7. This way you've got a duplicate in case something happens. Maya ate your file, it chewed up your folder, your computer crashed and corrupted something. All right, all of that is possible. It's a computer. All right, now you're going to be responsible for adding materials and color to all the elements that are visible in the render, just like project 6. You're going to be responsible for adding textures to all the elements or objects that require them. Like I said, not every object needs a texture. Most objects have UVs. However, they may not work with the texture that you are going to try to use. The UVs are on there. They're meant to look good in general, but you may need to adjust them to suit your texture. Some objects do not have UVs, like the wine bottle, the wine glass, the wine in it, the knife blade. Most of the time, they have materials on them. If you are thinking of doing the knife blade and you want to put some, dirt, wear and tear, maybe looks like cheese is on there and it's kind of blurred out the finish, well, then you will need to make sure it has UVs before you bring it into Substance or Photoshop. So, like I said, today we're going to be going into Photoshop. We're also going to be taking, once we're done with our repeatable brick wall texture, that will be our base color map. We're also going to show you how to make a bump map from that same file. So we're going to go over what each map is, what they contain, so that you'll know what you need out of that map to get what you want. Now, some milestones for you. So you must have at least one wood grained object and one metal object that you've made textures for in Substance Painter in your close-up render. Close-up render is where we can put detail. We can put a lot more detail on objects on the table because the camera is closer. You don't want to worry about putting a lot of detail on the door in the close-up shot because your camera is about 10, 12 feet away from the door. Doesn't make sense to have that much texture. Like from here, I can see that door's got a wooden texture, but I can't see much detail other than that. I can't see any cracks or dents or scratches or anything in it. But the close-up shot, that is where the money is. That's where you put your work. That's where you put the extra render time. It's got to look really good. Does that make sense? So for this assignment, do the minimum. Don't go, yeah, I'm just going to do all my texturing in Substance. No, you don't need to. Sometimes you can grab a photo texture off the internet, throw it on the surface, it will work, and you can run on and go do something else. Especially if it is not that close to the camera. So a lot of people completely misunderstand this assignment and they think, oh, textures, got to do it all in Substance. I'm going to do all my texture. Yeah, but you're not. You don't need to. All right, milestone 10, when we get to lecture 10 on Wednesday next week, we're going to be working in layering in Maya. Maya's got a layering system that will allow us to layer textures on top of each other so we can get a much more complicated effect. Very similar to Photoshop in the way Substance does it, only it's Maya and it's a little more archaic, but it's still functional. We're going to be doing a projection in Maya. You must have at least one projection done in Maya. You can do as many as you want in Substance, but we still need one done in Maya that's visible and noticeable. Like I said, for the interior, we've got the AAA logo that can go on the thermos. Got the SAL logo. You want to throw it on the desk or the wall or something. Exterior, we got the SAL logo. You can put your initials in there. You can put something in there as long as it is appropriate for all audiences. No graffiti that is offensive, expletive, or any kind of incendiary, like hateful stuff. None of that. We only mention it because it happens occasionally. All right, lecture 11, we're going to be kind of wrapping stuff up. Give you a couple tips, tricks, go over stuff at the end, but it's mostly working, getting stuff refined, getting a critique. All right, so like I said, the deliverables are down here. We've also got student examples of what was done. So again, level of detail, pretty much going to be really noticeable in the close-up shot. The long shot, yes, you'll see it, but you're not really going to be able to pick. It's going to be a little more impressionistic than the close-up. Level of detail on modeling. How much effort do you put into something that's really far away? Not a lot. You want to get the shape. You want to get it so it looks good to the camera back there. Now, obviously, if the camera is going to move and do a zoom in, well, then if you're taking it into a game, you probably do some level of detail swap outs. You know, when the camera gets closer, it's going to swap it out for a higher res model. But for texturing, you can kind of get away with the same thing. We are not moving the camera, so you've got two locked in shots that you can easily plan and see, what do I need to put the detail in? Well, obviously, it's going to be the close-up and, you know, secondary, some noticeable stuff in the long shot. Now, that's not to say that the same texture you've got on the close-up, you shouldn't use on a long shot. No, definitely. But it's going to be more noticeable in the close-up. All right, so here are your downloads down here, the SAL logo, Thermos logo. Give you the bread reference again, just in case you forgot it from the last time in Project 6. You can go back there. Believe it or not, this bread reference that we give you also works as a texture for the bread in the outdoor scene. Like I said, we used it to model from, and the UVs are kind of laid out to work with the same file that is a reference. Now, that doesn't happen all the time or doesn't work all the time, but it works for our shot with the camera. All right, so brief overview. Let's go on and talk about our different maps. So base color or diffuse color, however you want to look at it, it contains color information, okay? Texture, any kind of visual surface detail. Wood grain here, for this example, you can see I've got a 12-inch vinyl tile, a floor tile that you could not describe with a single color. Now, sometimes you will use color maps for solid colors, but usually when you have more than one color. For example, the back wall in our classroom. What color is it? Yeah, bluish, greenish, however you want to look at it. Turquoise, yeah. Right. Would you need a map to describe that color? Anybody? Why? Say again? Okay, but we could do that with a single color in the color swatch. We wouldn't have to plug a map in for that. Say again? Okay, however, can you see now? That wall has the same texture as the front wall. Can you see the texture on the front wall? Okay, so like I said, level of detail. So would you need a map to describe the front wall, which is white? No, generally not. Not unless you are close, about 2, 3, 4, 5 feet away. All right, so how about this side wall over here? My right, your left. Why? Yep, it's got two separate colors, more than one color. You can't describe this combination with a single color swatch. So that little color chip, think of that as one little pixel of color that covers the entire surface. Does that make sense? So when we say color, more than one color. All right, and for all you people in Zoom, that's kind of the wall we're talking about right there. You can kind of make out the fact that it is green and white. It's kind of a combination of our back wall, which is green, and the front wall up here where I'm sitting, which is white. So that, when we talk about more than one color, is what we're referring to. So if you've got wallpaper on that wall and it's a floral pattern, you need a map to describe that. If it's stripes, you need a map to describe that. Solid color, not necessarily. All right, so color, more than one color. Texture, any kind of visual surface detail, meaning I can see two colors. It's a floral pattern. It's a gradient pattern. Maybe somebody's taken a big stencil or a big map and just covered the wall with it, where it contains more than one color, but the colors fade very subtly into each other. That's a little more complicated than just a striped surface, but you would need a map for that. Okay, base color maps get plugged into the base color of the AI standard material with a file node. Make sure that your Maya color management is turned on. Needs to be turned on, or the colors and the lighting may not look correct. All right, does that make sense? Question? Okay. So let's go take a look. I'm going to skip a slide. We'll come back to that. Let's take a look at simple specular maps. Specular maps are used to control the amount of reflectivity on a surface. In particular, when you have more than one level of reflectivity on a single surface. When it's not all uniform glossy or uniform dull or uniform shiny or uniform rough, you've got some areas that look rougher than other areas. You need a map to describe that. Now, also, when we say more than one level, we also mean different amounts of reflectivity. No yawning. Different amounts of reflectivity. We use black and white info or information to control this map. So if you remember, when we drag that specular weight, which is where the spec maps get plugged into, it goes from 0 being no specularity or making the surface diffuse to 1 being fully reflective or as reflective as the material will allow with just specular. And we can use black and white information for that because 0 equals black and white equals 1 in Maya. Also in Photoshop, in Substance, in Unreal, in Unity, pretty much any program. All right, so we have areas that are really super glossy or reflective. They're white. White equals 1. Areas which are non-reflective or black equals 0. And anything in between. So for example, I've got a mug here and it's got some various, dried water stains. It's got fingerprints on it. So we got little areas of smudge here that knock down the level of reflectivity on the surface. So normally, if I didn't have this decal here, I could just throw a single color onto that mug, make it really nice and shiny like a, like a ceramic mug would be, because it's got glaze on it, it's been fired, it's relatively smooth and relatively shiny. But as soon as you start to add a little wear and tear, a little usage on it, things start to change. Stuff gets worn down during the day, the usage. I mean, think of a nice, clean, regular, clear drinking glass. You use it a couple times, it's no longer going to be pristine and clean and clear. It's going to have water stains on it, maybe smudgy fingerprints, depending on what you had to eat. You transfer that to your glass. It all starts to take away from the reflectivity and also from the smoothness of the surface. All right, does that make sense? Questions? All right, so like I said, spec maps get plugged into the specular weight with a file node. So we use specular maps when we've got more than one level or different amounts of reflectivity on the same surface. You can go in, you can paint them in Photoshop, you can paint them in Substance, which is basically what you're doing when you go into Substance and you start painting on a 3D object. You're actually painting on the UVs. And that transfers to a flat two-dimensional map. So when you've got a spec map in Substance, you're going to be taking that out and that's going to get plugged into your specular weight. Now, sometimes if you're working in Substance and you don't have different levels of reflectivity, your spec map may look all the same color. It may look gray, it may look black, it may look white, it may look something in between. If it doesn't have any detail in it, chances are you may not need to put it in the material. Just because you got a map out of Substance, make a decision, do I need to use it or not? All right, so roughness. So different levels of roughness on the same surface require a map. Again, it's black and white information. Black is 0, white is 1. So any area that you want to be perfectly smooth is going to be black. Or maybe just it's got a little bit of roughness in it, so maybe it's not perfectly 0. It might be 0.01, 0.02. Remember, nothing's really pure black or pure white. And then you've got areas that you want to be rough. 0.2, that's 20%, basically 20% roughness. That'd be roughly what you would use in Substance or in Photoshop. 20% gray. Or actually, it would be more like, yeah, it would be 20% gray. Be black? No, it would be the opposite. Be 20%, it would be 80%. Since it's backwards. You start black and you go white, as opposed to starting white and going black. So you can see here, phone case, got a couple of them. This is my old phone case. You can see areas where it's been subjected to keys in my pocket, getting scraped on the ground, dropped, roughed up. And you've got areas that are still fairly smooth and still have some detail, although they are a little blurry, but not as blurry. And you've got some areas that have definite little scratches all around it. So all these different levels of roughness, you need a map to describe. So more than one level of roughness on a surface. If you've got uniform roughness, hey, that's when we use just the roughness control. It applies the same roughness to the entire surface. All right, so over here, my newer screen case or a phone case, you know, not quite as beat up, but it does have a few little nicks and scratches and dents, and it's been scuffed up in certain areas, but not as much. So I would need a much, I would say, simpler map for that. Again, roughness maps go into specular roughness with a file node. Again, like I said, black and white. All right, questions? Anybody? Zoom, any questions?
I'm good for now.
All right, thank you,
I'm good.
Nelson. All right, good for now. Okay. All right, so here we have an example of my trusty old tablet. You can see there's some areas like around the edges, which are particularly rough, and areas in the middle where I scrape the pen across it all the time. Not quite as rough. It's been kind of smoothed out. The edges, which have a different kind of material on it. And you can see, let me zoom in on the close-up here. So you can see that I've got some real scratches in here. So all of this would require a map. Now, this would also have at least 3 different kinds of materials. Right? So we got one material here to describe the area that the pen uses and the tablet tracks. You've got the frame on the outside here. That has sort of a very kind of microscopic, grainy look to it. Let me zoom in a little more. So it's almost got a noisy, wavy, not a wavy, but a noisy pattern in it. So that's got roughness. Zoom in one more level here. So almost a sandy kind of appearance. Go back to 200. There we go. All right, so now we've also got this really smooth area over on the left side. It's almost similar to the way the back of my mouse was when we first started talking about materials in lecture 6. Back of my mouse was hard, smooth, dark, well, I don't want to say black, but dark gray plastic. Same thing here. Now you can see this has got all kinds of dust and particles on it. You know, it looks really disgusting. It's not as bad now since pandemic. I've been wiping it down with wipes, so it doesn't look nearly as bad. But The idea is you would need a map to describe all these little kind of like watermarks, dust, debris, just smudges from being picked up and carried, and just different environments, hot, cold, wet, dry, doesn't matter. So for this, you would need a combination of maps. You'd need a roughness map to describe the areas that are definitely roughed in. You would also need a spec map to describe the areas that don't look as rough, but have definite less reflectivity, like some smudges, some of those little water stains, the little droplets, the dust particles on them. We really don't have enough information to say whether it's rough or it's just low reflectivity. So you have to kind of make a call. Which one does it go in? Maybe it goes in both. So roughness map, spec map. If we were doing a close-up here, in this area, I can see those little indentations. Those little indentations would require me to use a bump map. Now, if you're doing this in real time, it would be a normal map. You'd have some kind of height information because those scratches look like they go down. For this area here, this could also be a bump map as well, because all of the detail that we see, is it a result of just smooth visible texture, or is it due to the uneven, not quite microscopic, but very fine levels of imperfections or irregularities in the surface? A lot of that is due to the light that's hitting the surface. The areas that are darker are indented. The areas that are brighter are come up off the surface a little bit. So that is really kind of a combination height map, roughness map. Sometimes height maps will create the roughness for you. So you might have a combination roughness and bump map. Now, all of these maps use black and white information. Okay, spec, if it's black, there's no reflectivity. If it's white, it's full reflectivity. For roughness, if it's black, it's perfectly smooth. If it's white, it's perfectly rough. Generally, we don't go all the way to 1 with roughness. Usually keep it around 50% or possibly lower. For a bump map, we use that to control, like I said, it's really an illusion. The illusion of visual surface detail. Like I said, it has to do with the angle of the normal to the angle of the camera. When the camera is looking at the object, that normal is pointing directly at the camera, we see the most bump effect. When it starts to get around the 90 degrees, the bump effect gets lessened. So again, black and white information. White is raised off the surface. Black looks like it gets indented or etched into the surface. If you want no visible bump at all, it's 50% gray. So a lot of times with these various maps, we may start off with a 50% fill. That way we can paint in darker areas, paint in lighter areas, and have them look like they come up and down or do different things on the surface. Bump maps get plugged into the geometry section. Remember, we used geometry for thin-walled when we did window glass. Now we plug our files into the bump mapping section with a file node. Now, when we do that, we automatically get this thing called a bump utility. We don't have to go searching for it. It's automatically put in for us. That bump utility gives us two controls. Actually, one control and one that has the file plugged into it. So the way bump maps work is using the value or brightness of your file to get height information from. Okay, the brighter or whiter it is, it's going to look like that part of the surface gets raised up. The darker or blacker it is, it's going to look like that area goes down. So when we take a file and we plug it into bump mapping in the material, your file is going to be attached to the bump value automatically. Our control for the amount of bump is called bump depth. No yawning. All right, bump depth starts off at 1. But it can be lowered, it can be raised, we can even go negative. Now, why will we go negative? Well, suppose you throw your bump map on there, your height map, and all the stuff you thought was going to raise up off the surface looks like it goes in. Well, then you got to go back into Substance or Photoshop and you got to invert it. You got to take what was dark, make that light, what was light, make that dark. But in Maya, we can just take the bump from +1 to -1, and it will invert the bump effect for us. So negative numbers reverse the direction of the bump. Just be aware, the default value of 1 is usually way too high. Questions? So this is all the stuff that we're going to be thinking about for the end part of class. So you really need to know what you see, what you're looking at. What do I see? Is that a result of just different colors, like a wood grain? The grain of the wood is usually darker than the wood itself. Or is that a result of height information? Am I seeing shadow, very subtle light and dark areas? Now, when we start to plug files into our texture, we're going to be using the default texture mapping method. So our file node's going to go right into whatever channel we plug it in. And in addition to the file node, we are also going to get this thing called a Place 2D texture. Place 2D texture gives us some control over UV. It's not going to take the place of the UVs you have on there. It's going to give you the ability to shift the texture across the UV 0 to 1 space, rotate it, or in the case of trying to make a texture or a pattern repeat, copy itself. And as it copies itself, it's going to reduce itself. Remember, most stuff that you plug into a texture, into a file node that's going onto a surface, is going to take up the entire 0 to 1 space of your UVs. If you do that and the texture looks gigantic, so in the case of wood, it's meant to look like a little small board, but it looks like a tree trunk. Well, then that scale needs to be brought down. You either have to have it repeatable so you can scale it so it gets smaller and smaller, or you have to find a texture that works with the size that you have if you don't want to scale it or repeat it for whatever reason. All right, so it kind of makes sense when we start to go over some of these parameters in a really quick, simple demo. All right, so like I said, texture mapping, it's the default. Texture is applied to the UV space of the surface. With that place 2D, we have some control over where that texture lays. But again, it's going to be based off of your UVs. Now, something that you may run into when we start adding textures. We wind up taking, we've got our scene that we did the lighting on, you put the materials in, you got everything looking pretty good. We got to throw a texture on there, and then all of a sudden, that texture is completely blown out. So right here. And your first impulse would be, let's lower the level of light. But the problem with that is, you lower the level of light for one surface, what happens to the rest of the scene? Everything gets affected. So instead of doing that, what we do is we adjust the base weight of the material that's assigned. The base weight starts out at 1. That accepts all available light on that material. As you start to lower the base weight, you decrease the level of light that the material responds to. So consequently, this is with the default base weight of 1, which is the default. And then we just lower it until it matches our reference, till we can start to see some detail in our texture and it starts to match the reference. All right, now, what I'm going to do is I'm going to demo the outside like I did in lecture 7 with the glass. I'm going to go in there because I know there's a lot of light in there, just like there is in the interior. You may run into this in the interior day. Nighttime, you're not going to have as much trouble with really super high levels of light, right? But sunlight during the day, if you put it out there, put an object out there and take a picture of it, depending if your camera hasn't had time to adjust itself, it will take a picture and everything will look blown out. So instead of us adjusting the camera, we're adjusting the material so it looks good to our Maya camera that has no automatic exposure, color balance controls, doesn't have anything like a real camera does. So I'm going to take the Zen Garden exterior day. What I'm going to do is use the same file I used in lecture 7. I'm going to add a sphere and stick it on the table. That sphere is going to be there for me to demonstrate to you guys, and you can follow along if you want. Simple maps and how they work. And what do they do under ideal conditions? Just so you can visually see how the material responds differently. All right, so let me clean this up. And do I have Maya running? No. So let's fire up ye olde Maya. Like I said, I'm going to use the Zen Garden exterior that I used from project 7 or lecture 7. In fact, I'm going to take that same file and copy it to my project 7 folder. All right, good. All right, so we go back here. All right, so here is my project 7. I got the Zen Garden, I got the interior. I'm going to take my project 6 that I did in the Zen Garden demo the other day. So I'm going to take that, copy it, put it in my project 7 folder right here. And let's take all the stuff from last month and just throw that in there. There's my project 6. I'm going to rename that to 7. And for this, let's rename that lecture 8. All right, so set my project first. Why? Because it's a separate project folder. Project 7. Yep, that's it. Let's hit set. Let's go file open and let's open our daytime Zen Garden that I did. All right, ignore that. And let's go to the render cam. Let's make sure that just because I copied it, make sure nothing got disconnected like the dome light. All right, that'll work. All right, so what I'm going to do here, make a simple polysphere, stick it on the table, kind of next to the wine bottle, behind the wine glass, next to the bread, just so we can start to play around with simple maps. So just going to create a polysphere. Go into perspective. Let's pull it up off the ground. And looks like one of those giant beach balls. Hilariously large. So there's the table. That's it right there. Let's scale it in because that's way too big. Just trying to make it so it looks like it sits on the table. Close enough. Simple polysphere, like I said. Let's make sure my bookmark is good. Close up. There we are. All right. So at this point, simple sphere. Let me hit 3 to approximate smoothness. Assign a new Arnold material to it. And I'm going to leave the default Arnold settings, except for the color value. I'm going to lower that so that it doesn't look too blown out. But first, let's assign the Arnold material. All right, so that's going to be my sphere. Call it my demo sphere. There it is. So default, what I'm going to do is lower my value so that I can actually see the reflectivity. All right, I'm also going to lower the roughness to 0. There we are. And let's just kind of zoom in and fit that. All right, so we can see some detail in there. And all I'm going to do is, let me just crop the sphere so we don't have to constantly redo all the transmission and refraction in the bottles all the time. There we go. So that'll help. All right, so uniform color, uniform reflectivity. And for this demo, what I'm going to do is start off by showing you a little bit about that base weight. So let me go back to the render cam. Actually, no, let me stick in perspective. What I'm going to do is select my table. And I've gone and I found a texture for the table that I want to use. So I've got a ton of files in here. So I went out and found this wood plank texture. It's pretty big. And that happens to work out pretty well because those boards are roughly the size of my boards on the table in the Zen garden. So I was able to find a decent texture, decent size. So that's what I'm going to use for this table. Now, when I assign it to it, I'm going to obviously check the UVs. I know the UVs work because I've used it before. But like I said, if you assign a texture and your UVs don't work, well, then you need to just rearrange the UVs so they do work inside your texture. So let's see what this one looks like. All right, so I'm going to assign a new material to the table. And the reason I'm doing this is because I want to show you what happens with the default base weight on a texture in a bright, sunny environment. All right, so Zen garden table. Now, this is going to be a color map. This is my base color. Base color maps go into base color in that little checker next to the swatch. That brings up our create render node, and we want a file. Pretty much for this, you're usually going to grab a file because you're going to be bringing things from outside of Maya into Maya. Stuff you did in Photoshop or I was going to say ZBrush, but not ZBrush, in Substance, or you've just gotten off the internet, like I got that wooden plank, and throw it on and see what it looks like. So 2D, and there's my file. Now that's going to bring up, well, it should take you in the attribute editor to your file node. If for some reason it doesn't, open up the hypershade. You can go into the hypershade. There's my new material, Zen garden table. Select it, right click on it, graph network. There it is. My material, there's my file node, there's my place 2D. All right, now let's select the file node and image name. This is where you're going to plug your actual file in. All right, so I've got Zen garden source images in my source images folder, going down under C for affordable, and there's my wood plank. So I'm going to click open. And let's take a look at the UVs. There we go. So these do line up. I can see some spots here where some of those little pieces of board might be in a void or a crack. If they're not visible to the camera, I don't have to worry about it. Yes. Oh, it's under the UV menu. I usually have modeling running all the time, that modeling tool set, only because most of what I want in shading and lighting is either in the create menu for lights, or I can just do Shift T to get a new Arnold material on there. And if I need Arnold stuff, it's on the shelf. Some people like to work in the lighting shelf. I do more modeling stuff than I do anything else, because we're usually worried about the geometry. So like I said, just select the surface, go up to the UV editor, take a look at it. It looks like it'll work okay. I got lucky. Doesn't always work out that way, but if it didn't, and I actually had to relay the UVs out, that's a simple thing to do. I could just do planar projections and just put the stuff and move it around and rearrange it. So far, so good. Let's see what that looks like when we render. So you can see that's what it looks like with kind of default lighting, the viewport issue, standard, blah, nondescript lighting. And then here, you can see this is what it looks like in the lighting in my actual scene. So I got a lot of energy in there. It's pretty bright. What I need to do is find a way to control how much light that surface is responding to. And that is going to be inside my material in the base weight. So base weight at 1, it accepts all available light intensity. So once I start to drop it down, you can see it starts to respond to less and less light. Now, here's the danger of using too much base weight. It looks like it belongs in a different environment now. Everything else is super bright, but that is super dark. The idea is you want to match the level of brightness that you see in your material from your reference. Use your reference. Can you see detail in the wood? Probably. Like if I go back and look at that Zen garden picture from the photo reference we gave you guys, I should be able to see, that's in project 5. Right there, photo reference, right there. All right, so kind of far away. Zoom in a little bit. So you can see it's a bright sunny day, but I can still see some detail on that table pretty good. Got any other? I don't think I have any other close-ups of the table. Well, those are the wood planks that you can see, those horizontal wood planks, and you can see the vertical ones. They're steel, just like the frame itself. Here you can definitely see those wood slats are inset inside. All right, so go back. That's good right there. So usually what I wind up doing is I will start bringing down my base weight, either 0.1 or maybe 0.5. So if I go down, no, I don't want to go down 0.5, but like 0.05. So if I start at 1, I might go 0.95, 0.9. In this case, I've gone down to 0.8. It's still pretty bright. So let's try, let's try 0.75. All right. Well, let's take a bigger jump. How about 6.5? Looking better. 0.6. About 0.5. So at 0.5, we've almost cut the light that the material is accepting in half. But the material's starting to look better. The texture on it is starting to become noticeable. Now, what you want to do is you want to have the material or the texture be visible and noticeable, but you don't want to make it too dark so it looks out of place. Just realize that in a bright day, not all your detail is going to be visible. Some of the lighter areas are going to get blown out. They are going to be kind of bleached by that sun. But somewhere around here, maybe here, that might be a little on the dark side. I honestly don't mind if it gets a little blown out, but I've got detail here. Now, as far as my base or my specular weight, I can honestly say that that's wood, it's outside, it's fairly rough. Unless it has a visible shine on it, which those Zen Garden tables, they are out there all season long. They get refinished like once a year. Unless you catch them as soon as they've been refinished, they are pretty rough. So generally, there's very little to no reflectivity on that wood. So I turn that off. That will also help some of the areas that may have been too reflective and blown out. All right, so this is after. This is before. So you can see the difference. Does that make sense? So base weight, you got an object like I'm thinking of the interior. If you did the daytime, that computer desk in the close-up, there's a lot of light coming in through the window there. That may get blown out. On the floor next to the sofa, you got a nice parquet floor, or you got, maybe a tile floor that you put on there. That's getting blown out. That's a good chance to try out lowering the diffuse weight on that material. All right, so now, any questions about that? Make sense? Base weight? Zoom, any questions in Zoom?
I'm good.
Okay.
I'm good.
All right, thank you. So, yes. Well, once you put a texture on, you may have to go back in and adjust, yes, the roughness, the specular on it, because it's going to look a little different once you've got visual detail on there, on the surface. But again, go back to your reference. You probably will have to adjust, if it's daytime, you probably will have to adjust the base weight. Because generally, when you throw a texture on there, it's going to have, if it's a JPEG, it's going to have the usual compressed, very kind of low, narrow color range and dynamic range. And as a consequence, it usually comes in looking really bright and sometimes blown out. Now, when we get into Photoshop, I'm going to show you guys how you can tweak an image just using Photoshop's curves, because a lot of times when you bring photo images in, there's a lot of what we call midtone information, like midtone grays, 50% gray around that area. Take pictures of faces. Faces, there's lots of gray detail on there. And what you want to do is you want to adjust that mid-tone range to bring out more detail, which will in turn give you a little more visual pop in your textures. And also a lot of times if you brought an image in from the internet, it comes in, it's been compressed, it's been uncompressed, it's going to look a little blurry. We can sharpen it up in Photoshop too, which will put a little bit of sparkle back in the textures, hopefully. Okay, so good question, Ross. All right, so let's play around with throwing some maps on to this sphere. And let's do the close-up here. There we go. All right, let me just kind of crop that area out. Makes it much simpler. All right, so I'm going to select my sphere. And now by default, you can see my specular weight is at 1. It's uniform across the entire sphere. What happens if I want to have more than one level of reflectivity on the sphere at one time? So let's see what that actually looks like in a map. Now, for these maps, I'm not going to actually use a file map. I'm going to use a very simple Maya built-in procedural texture called a checker, which you guys are probably familiar with. Simple black and white, so we can throw it on there and see what black does, what white does, and then we can adjust those blacks and whites and make them gray, so you can see what happens when you start having different levels of gray in there and how it appears in your render. So spec maps get plugged into specular weight. So next to specular weight, I'm going to click that little checker input button. Create render, node 2D texture, and we're going to go simple checker. Now, before I click that, let me kind of save this render right there. And let's click checker. So now by default, once that pops in there, and these are just the default sphere UVs, it works perfectly fine. But you can see anywhere that is black, we've got no reflectivity. It is diffuse. Anywhere that's white, we've got 100% reflectivity. Now, the reason I like the checker is because you can go, well, there's never pure white, so let's knock that down. There's never pure black, so let's pick that up. But now you've got a more subtle representation of multiple levels of reflectivity on the surface at once. So again, there's our nice uniform default specular weight of 1. And now we've got a map on there with different levels of specular weight to knock down different areas. Now, think of this checker map that I'm using as kind of a placeholder for like a water stain map or some map that you've gone in and painted. You've got, a map with a bunch of fingerprints all over it. So maybe somebody was handling the sphere. So you got fingerprints all over it. Areas where fingerprints are would be less reflective. Areas where, the ball had not been handled would be a lot smoother. All right, does that make sense? Questions? All right, we got any questions in Zoom?
I'm good.
Okay. Thank you.
I'm good.
All right, thank you. All right. So what happens when you plug a texture in and you go, oh crap, I didn't want to put it in there. I plugged the wrong thing in, or I put it in the wrong spot. How do you break a connection once it's in there? There's a couple ways you can do it. One is you can do it in the attribute editor. The other is you can do it inside the hypershade. So now let's take a look at what this material network looks like in the hypershade. So hypershade, there's my demo sphere. Let me right click and graph it. You can see there's my checker. It goes into my specular weight. And here's my place 2D texture, which we'll get to in a second. Now, easiest way to break a connection, if you go to the material itself of the object, go into the attribute editor, go down to the material attribute you want to remove the file from. Mine is specular weight. Go on top of the name of that attribute and right click. You've got an option to break connection. Now, when you break connection, it will usually put the setting back to where it roughly was from the file. Like I had it about 50% because I had two channels in there. One was black, one was white. Don't forget, what you need to do is turn that back to its default. That way your attribute's back to where it was. Now, what happens in the attribute editor, once I removed it, is now my material does not have anything plugged in. My little connection noodle that went from the checker to my specular weight is broken. And this is discardable. You really don't need it. Now, here's something that you may not get to experience unless you're aware of what goes on in the hypershade. So if I didn't have the hypershade open and I broke that connection, when I open the hypershade and graphed my demo sphere again, notice that the other pieces that were there, that checker pattern and the place 2D, don't show up because they're not attached. Don't think that they don't exist anymore. They are still buried inside Maya. So for example, there's a textures tab up here in the browser, and there's my checker. And under utilities, there's a whole bunch of stuff that we did the other day. So here's the thing. If you make and break connections, after a while, you're going to have a lot of unused textures and unused utility. What you want to do is, before you're all done and do your final render, in Maya, first off, save your scene. Why? Because this is destructive. Save your scene in the hypershade. You go up to edit and delete unused nodes. That will remove any materials that are not assigned to an object, any textures, and any utilities that are not being used. Remove them completely from the scene. So watch what happens with my checker when I do that. Delete unused nodes. It's gone. Under utilities, it got rid of the place 2D I wasn't using. If you've had any materials that you've made and assigned them to an object and then reassign something else, any unused materials will be removed also. That will optimize your scene so when you go to render, the renderer doesn't have to go through all those empty nodes. So Little bit of housekeeping goes a long way when you're going to do a final render. Now that we got rid of all that stuff, let's do the same thing. Let's take a checker and let's put it into roughness and see what happens. All right, so specular, roughness, click the little checker button. 2D textures, there's the checker map. And it sort of gives us the same result that we had when we plugged it into the reflectivity or the specular weight. But the difference is areas that are black are completely smooth, areas that are white are completely rough, but we can dial down that level of roughness. And we can bring up that second color to make it kind of more or less. Haley, you have a question?
Why?
Okay. So we can also bring up, the areas that were completely smooth and make them not quite as smooth or as perfect. But now we've got multiple levels of roughness on the same surface. Fingerprints, scratches, imperfections, areas that maybe greasy fingerprints, greasy smudges are really good for roughness because all of that grease actually creates a little film on the surface that really becomes noticeable. It's not just about reflectivity, it's about the surface being broken up when light hits it from that grease or contaminant, whatever it happens to be. All right, question. Questions so far? Anybody in Zoom? All right, no reply. Going to assume everything's okay. Unless, of course, we're having internet issues.
All good.
All right, thank you. All right, so let me stop that. And what I'm going to do is select my object again, go in, break my connection for the specular roughness. Now, if you go on top of, most of the time, unless you're somewhere on top of the name or in that channel, you have to make sure that you're over, like I said, the name or in this case, you can actually go over top of the numbers in the channel and you can break connection that way. Yes. You would have to, what you would do, I mean, ideally with a map like this, yeah, the base weight. Now, I see what you're saying. That the thing with roughness is if you need to make it like the whole thing less rough or more rough, you're better off either going into Photoshop or back into Substance and increasing the numbers that are in there, making the map brighter. There are ways to do it in Maya, but ideally, that's just a Band-Aid on a problem that you really want to fix. Yeah, now there are things you can do. I'm not saying you can't. It's just that usually this is kind of why everybody prefers Substance Painter. Because what you can do is you could actually bring in the Zen Garden image into Substance, put it in there, kind of get the levels that you want, and they would be pretty accurate with what you're doing. Overall, if there's too much reflectivity, too much roughness, since it's all under the specular, you can adjust the weight overall. That would work. But there's no guarantee that it would for like the bump map or anything else. No, you have to use the lights that are in Substance. So there are workflows where you can actually work in Substance and have the work brought over to Maya or brought over to Unreal while you're working. That requires a lot more beef than a laptop, honestly, because you need both those apps running. They have to be able to talk to one another. That's really where you get into like full-blown production pipeline software that can actually push and pull information really quick. Like I said, there are ways around that. There are utilities in Maya you can use, but I don't want to get into that just yet. Remind me like on the last day, and I'll show you a couple tricks. Yeah, I mean, if you're still having trouble, it's just, I don't want to overload you with too many things like right now. I just want to have you get the basics, and then there's ways around everything. Good question, though. The geek in me wants to just go, yeah, you can do this or this or this or this or this, but that's like information overload. Sometimes I have to like constrain myself. All right. Now, the last thing I want to take a look at are height maps. And for height maps, I'm going to use a built-in Maya procedural that is not the checker. It's going to be something called a noise, which is very similar to the noise procedural you get in Substance. It just breaks up everything kind of randomly. It creates a really kind of grainy look to it, almost similar to that the grainy look that I have going around my tablet right here. So for bump maps go into the material geometry section. We have the bump mapping control. Now, when you click bump mapping, that little checker button next to it, it brings up the usual create render node. And 9 times out of 10, you're going to be bringing in a file. This is the 10th time where we're doing it as a demo. We're just going to use a built-in Maya file called a procedural. So 2D texture, we go down to noise. As soon as I bring noise in, you can see what happens to my object. It kind of looks like a glass sphere that got packed with a lot of dirty, material inside and didn't quite, it's got air pockets and didn't quite get shoved all the way to the edges. So where you see the really smooth areas, that's going against the complete like 1. That's the most amount of bump you're going to see, and all the other areas that go indented are the black areas. Now, you'll notice that the value control is yellow. That's because that's where your file gets plugged into. In this case, that is my noise, which is just black, white, gray, random all over the place. All right, let me go back. So when you graph this network, let me stop this. When you graph this network, you will see that we are all the way down here. And notice how in the material, it's called geometry, bump mapping, but In the hypershade, it's called normal camera. Very confusing. But there's your bump node. There's the noise that's driving the bump. Anywhere it's white, it's going up. Anywhere that's black, it's going down. Anything that's 50%, it's kind of remaining flat. No change. And then here is our place 2D texture. Now, first thing I'm going to do, before I start adjusting anything, I'm not even going to play with the noise because that's irrelevant. That's just there as a random texture. What I want to do is play a little bit with this place 2D and show you how that works. So in my hypershade, I just select the place 2D. And you'll notice you've got a coverage of 1:1 in your place 2D. The first column is U, the second column is V. So you'll notice coverage 1 in U and 1 in V. That covers the entire 0:1 frame. So that noise is covering the entire surface. We can translate the frame. Right now it's anchored at the bottom at the 0,0 space, but we can move it around wherever we want. We can also rotate the frame, which will actually of course, you have to actually render it, which will actually rotate that whole editor frame around. Now, something like this, usually anybody who's interested in animation, as soon as they see something like this, they go, "Ooh, can you animate it?" And if you right click on any attribute in Maya, if you right click and it says set key, yeah, you can. So you can set this and have this whole thing kind of change and undulate over time, which is pretty cool. So now that's rotating the entire UV frame. Actually, no, wait, that is the entire texture frame. So if you brought a texture in, it would be that image, it would just rotate the image. Since this is a procedural, it just rotates the procedural information around. You can actually rotate the UVs here under rotate UV, which will give you the same effect. Honestly, I don't like to rotate the UVs. If I want to rotate them, I go into the editor. But if I want to rotate the texture itself, then I rotate frame. This way, you're not screwing with your UVs and mess them up. Now, the repeat UV, this is where it gets interesting. Right now, that texture is really large. It kind of looks like a boulder that has a lot of, nooks and crannies and crevices in it. If I want this texture to be smaller, I have to repeat the texture more across the 0:1 space. So right now it's in the frame, filling the entire frame at actual size. So if I want this to be smaller, what I'll do is increase the repeat U to 2, and then the repeat V to 2, and now it's basically made it twice as small. Want to get it smaller? Let's keep going. Let's go 3. Let's go 4. Let's go crazy. Let's go 8. So you notice the smaller it gets, now it's starting to look almost like a ball that's been chipped away and some of the areas are smooth. Let's go 12. Now we have absolutely no roughness on that surface, but given how you can see some areas that look smooth and other areas that look like they have indentations, it creates roughness on the surface because it is the illusion of surface relief or having the surface actually modified. But we haven't done anything to the surface. Now, the thing about bump maps are the amount of bump is always way too intense at the default level of 1. So usually we recommend when you're working with bump maps, take the bump map, and it's called bump depth. We take that from 1 to 0.1 and start there. That is usually a much more subtle bump effect. So now to get to that bump utility, let's go over here. It's right here. I've got my hypershade open. Bump. Let's knock this down. And I don't use the slider. The slider's garbage. Because you grab it and all of a sudden you will be in the negative numbers. So let me go to -1 and you can see there's -1. Here's +1. Really kind of subtle, but we're just kind of shifting stuff. We're just flip-flopping black and white. Now, like I said, we usually recommend starting the amount of bump at 0.1. Doesn't look all that different from the default of 1. Don't be afraid of going even lower. So watch what happens when I take it down to like 0.05. Yes. Yeah, it's your material. I don't know if that's any better. Actually, let me do this. Let me break that color there. Let's do that. Let me zoom in a little more. And let's go back to the bump section. All right, so here's the default bump of 1. Get rid of this. Let's get rid of that. Let's keep that. Let's knock this down to 0.1. Doesn't look that much different. Honestly, to be honest, 0.1 is usually too much bump also. So we usually go down like 0.05. I usually like to go down to like 0.01. Now, once we start to lower it, you can see that now it's not so dark where the low areas were. And remember, this is all fake. So it consequently is trying to put a lot of extra shadow in there. And that's why it looks so dark. Now, let me knock down some of the reflectivity on this too. That might help. So this is 0.01. And you can even go down even more, like 0.005. Honestly, the best bumps that you'll come across are very, very subtle effects. You don't want to smack people over the head with a bump map because they'll go, whoa, nice bump. That's not what you want them to see. You want them to go, hey, that's a nice texture. And if they don't, say, wow, it looks good, but it's too smooth. If they don't make any other comment, then that usually means you've done a pretty good job matching the bump and the spec and all the other stuff, if it looks natural to them. The idea behind this is, though, if you've got a bump map on it, a lot of times that bump map will give you roughness also. Because, let me save this, if I turn my bump depth to 0, there is no bump at all, which you can see how that very muted, subtle bump roughens the surface and breaks up the reflectivity. But again, it's being exaggerated with those default settings. It's meant to look really dark, really deep, and it's adding a lot of dark areas in there artificially, kind of. So, bump maps, really useful, but just remember to be subtle with them. The default of 1, way too much. 0.1 is even too much. Don't be afraid of going down really, really low. Like I said, the slider is absolutely useless. You're much better just typing in numbers. Whatever number's in there, too much, cut it in half. Too little, double it. It's going to be a lot more accurate than just dragging the slider. All right, questions? Make sense? Good interaction, very good questions. Yes, go ahead, Ross. Yes. No, you're repeating that texture 12 times. So every time you repeat it, it has to make itself smaller to fit the same space. So we've made it basically 12 times smaller than it was initially. That kind of makes sense? And, when we went from it being 1, which it took up the whole 0 to 1 frame, when we went to 2, we basically made it twice as small. And each iteration, in order for it to fit inside that 0 to 1 space, you got to make it smaller. Does that make sense? Good question. And that leads me to what happens when you get a texture that is not repeatable, like these built-in procedurals in Maya. What I want to do is kind of show you what happens, and I'm going to choose that asphalt back here. So what happens when you've got a repeatable texture that meets a surface that is not square and doesn't necessarily conform to the shape of your texture? So let me assign a brand new AI standard to that asphalt. And I'm just going to call it brick. Now, in the brick texture here, we're simply going to assign let's take the Photoshop file that I give you guys. And let me get rid of all this stuff. That all goes in here. All right, so this is the default brick texture we give you guys. Let's take that. I'm going to copy it And let me put it in my project folder. Put it in my Zen garden images. Let's replace the one that's in there. Let's get rid of all the other stuff that's there. And what I'm going to do is I'm going to plug that default brick wall into the base color. I don't even need to render this because I'll be able to see it in the viewport. So for this, since it's a file, I use 2D texture file. In the file node, this is where I want to go. I've got my Zen garden source images. And I'm going to go down to my lecture brick wall. And there it is. So this is the default repeat UV of 1 and 1 in U and V. And you can see it's a little stretched because my brick texture is probably a little bit higher than it is wider compared to the size of this surface. So remember, this surface based on the size of that, your texture is going to force itself into there and fit that 0 to 1 frame. So now, let's go back here. Let's repeat it. So let's go 2 and 2. Now, when you repeat something in U and V, remember, it is not just repeating it twice, it repeats it 4 times. Because it repeats it 2 times in U and 2 times in V. So instead of just getting 2, you're consequently getting 4. Does that make sense? Remember, it's U and V. So 2 separate directions. Now, as it starts to repeat more and more and more, let's go to 3. As it starts to repeat, you can see that we've got a watermark. We've got, when things repeat, the top lines up with the bottom, the left lines up with the right, and that's how it repeats itself. It kind of stacks itself side by side, up and down. Now, as it's doing that, notice that the brick, since it's not repeatable, the top and the bottom don't line up correctly. There's no grout in between the top and the bottom brick. They don't line up. We've got a watermark in there. And as we zoom out, you can start to notice that it's repeatable, or it's repeating. It's got a noticeable repeat to it. And that's something we want to try to minimize by making it a seamless or repeatable texture in Photoshop. Does that make sense? Now, as you guys are searching for textures on the internet, if you think that your texture, you're going to want to resize it in your Maya scene, search for a seamless or repeatable texture. And also make sure you are getting at least a 1K map, 1024 by 1024, because anything smaller, and you're going to start stretching that image to fit. Or you're going to take a really small image and blow it up. And what's going to happen is the pixels are going to get really big and it's going to look awful. So you want as much resolution as you can get. The ideal is 2K or 4K maps if you can find them. The more resolution you have, the easier it is to scale up and down. So this is why we want to make this brick texture repeatable in Photoshop, which is what we're going to do when we come back from break. All right, so this is a good time to break. Any questions?
No, sir.
Say again.
I said no, sir.
Okay,
I'm
thanks,
okay.
Julio. Thanks, Nelson. So Ross's question is, if we use too many 4K maps, we're going to run into a memory problem. Honestly, yes. Stick to 2K for now for your laptop. If you're working on like a movie or a film, the bigger the resolution, the better, because then it's got to be good enough to hold up with whatever the production level of the camera is that they're using for the work. And plus, you know, it's going to be, most of your stuff when you guys graduate is probably going to be 8K, just to get as high quality an image as possible. So you can deal with running out of memory then. But for now, yeah, stick to like, that's why we recommend between 1 and 2K are good for the render sizes we're doing, because we're doing half HD. So yeah, that's a really good question. All right. So let's take a break. And when we come back, we're going into Photoshop and we're going to kind of make that brick wall texture repeatable. So let's come back at 3:25. We'll pick up and we'll probably run a little over past 5, just because when we're done in Photoshop, I want to bring it back into Maya and show you what it looks like once we fixed it. All right, so go on break, come back in about 20 minutes, 3:25, and we'll pick up and go into Photoshop to make that brick wall repeatable, or that brick texture, because it could be a floor, it could be a wall, it could be anything. All right, thanks for hanging in there. I'll see you guys in about 20 minutes.